All right, so welcome back to Dapp University. So today I've got another coding tutorial for you. I'm going to show you how to create a decentralized autonomous organization, or a DAO. So this is one of the hottest use cases for Web 3.0 technology that's getting a ton of traction. DAOs hold the potential to completely change how people coordinate online, from corporations to investment funds, anywhere where strangers need to, coordinate online to make decisions. And I first created this tutorial for my members inside of the Dapp University community at Blockchain Mastery University. But because so many people have asked me about this highly requested topic, I've decided to make this video public for you all, and you get the bonus of having a sneak preview. So if you like what you see today and you want to see more videos just like this, then head on over to dappuniversity.com/bootcamp to get started today. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something you're interested in, then definitely smash that like button down below and subscribe to this channel. All right, that being said, let's jump in and get started. So let's start off with the question, what is a DAO? Okay. So a DAO is a decentralized autonomous organization. That's what DAO is, D.A.O. That's what it stands for, okay? And really that is exactly what it sounds like. It's an organization that runs on top of the blockchain. It's decentralized, it's powered by smart contracts, and it lets people coordinate online in a way that they never could before. Okay, so DAOs have definitely caught the attention of the mainstream. This is an article here on Forbes.com, okay, talking about what are DAOs and why you should pay attention. So, it just says, can you imagine a way of organizing with other people around the world without knowing each other and establishing your own rules and making your own decisions autonomously, all encoded on a blockchain? Well, DAOs are making this real. So essentially, a DAO is just an organization that's run by smart contracts on a blockchain. That's what makes smart contracts so powerful, is they are they are programs run on a blockchain, okay? And a contract is just code that can't change, okay? That's the power of a DAO, is you can coordinate with people online across the world who don't have to know each other, where code is law. Code runs your organization, okay? And you can vote on things that you want your organization to do, like, do you want to spend money? Okay, do you want to hire somebody? Do you want to fire somebody? That's what DAOs enable you to do, okay? And that's why it's caught the attention, because this has the potential to replace, corporations, or enhance what they can do, and actually create new kinds of entities that weren't possible before. That's the promise of Web 3.0, is you can, coalesce people around some common vision, where the code, governs exactly what you decide to do. So let me show you the most common use case for DAOs as they're being used right now, okay? So basically, the easiest thing to use a DAO for right now is to decide how money is spent, where a bunch of people can get together and say, hey, there's a amount of money sitting somewhere in a smart contract, and we can all vote on how that money gets spent, okay? This has applications, in people getting paid. It has applications for investment funds, or anytime a community owns money that's governed by a smart contract where no individual owns it or controls it. That's the easiest use case, because DAOs, run blockchains. The easiest thing to program in an airtight fashion is how money moves around, because you have cryptocurrency in a blockchain, and then you can vote on how that money moves so that you can make decisions in a decentralized way. So that's exactly what we're going to create in this tutorial. So I'm going to show you, basically on my screen here, that we're going to have a treasury like this, okay? So this treasury is going to hold some money. Well, it's just for example purposes, say it's like $1 million. So $1 million in Ether, or Ethereum cryptocurrency, okay? And then we're going to have token holders who are a part of this DAO. That's what gives you membership, is you hold a special token related to the DAO. You might have seen this with like other DAO governance tokens, like the Uniswap token. The Uni token actually is a governance token for that protocol, okay? Or the compound token, comp token, is a governance token for that protocol. Lets you vote on what those protocols decide to do. So in our case, we're gonna have a fictitious DAO for Dapp, or Dapp University, and a Dapp token. And we're gonna have token holders like this, okay? And they are gonna vote on how money gets spent. And this, treasury is gonna hold the money, and then they're gonna decide who to send it to, and whether it should be released or not. We're gonna let people vote on it. Now, that previous slide was just a high-level overview of how the DAO is going to work, but here's an exact breakdown of every essential part of what we're going to create today, okay? So we're going to have several smart contracts on the blockchain that are responsible for this. We're going to have a token smart contract. All right, this is going to govern the actual cryptocurrency token that the token holders are going to possess, because you need a token in order to vote. Okay, this is going to be an ERC20 token. So we're going to create a token smart contract. All right, we're going to give the holders some of these tokens, all right, so they can actually vote. Now, the voting is actually going to take place with a different a smart contract. We'll get back to that in a second. But the Treasury, all right, is actually where the Ether funds are going to go. So we're going to have this Treasury here that holds Ethereum cryptocurrency or Ether, all right? And these voters here are going to vote on how they want this cryptocurrency to be spent, all right? We're going to propose some sort of recipient. We're going to say, hey, do we want this person to receive X amount of money? Let's say for a fictitious use case, it's, to fund a new project or something like that. Well, as a token holder, you can talk to this governance contract here, okay, and basically say, hey, we want to create a proposal that says, we want X amount of dollars or Ether to go to this recipient, for some reason. And you will add this proposal to the governance contract. And then once that, proposal is accepted, the token holders can then vote on this proposal. And if enough votes pass, you can specify how many votes you want to pass. Then the governance contract will actually take a special encoded function that is created in the proposal, and it will call that function on this Treasury contract to release the funds. That's what the governance contract does. Whenever you create a proposal, you basically tell it the function that you want it to call on a different contract. In this case, it's going to be release funds from this Treasury here. And then those ETH funds will actually get released to the recipient, okay? So the last thing to note here in this architecture is that there's going to be a time lock. So basically, there's going to be a small time delay in between, when the vote passes and when, stuff can actually happen. That's really common in DAOs. So like if somebody makes a decision, everybody has time to prepare for it and adjust, okay, to get ready for it. And so we're going to have a separate contract that's going to be a time lock that essentially, is a time delay in between the time that the vote passes and the action occurs, in this case, to release the funds from the Treasury to the recipient. All right, so let's go ahead and start coding the project, okay? So you should have a zip file down below that's going to let you download this code, all right, to install it. I'm just going to look at this GitHub repository here, just for some simple instructions while we're coding the project out. Okay, these are the official setup steps. You probably won't have access to this GitHub repository. Just make sure you check the link down below for the zip file. It will have everything you need. It'll even have this README inside of here so you can look at all these instructions, okay? So just go ahead and download that code, open it in your terminal, and we definitely want to do the first step, which is Npm Install, okay? So I've already done this step. It's probably going to just tell me I've already done it. But you need to do this step and make sure all your packages install, okay? So that's the first step. Now, there's also a prerequisite, which is you need to make sure you have your system dependencies on your computer, for Node.js, Truffle, and Ganache, okay? There should be some videos inside the Blockchain Mastery program on how to install these individually. If you don't, I just don't want to, take the time to do it in every single video, so definitely go check that out if you need to understand how to install these things, okay? So, now that you've got your system dependencies installed and you have done npm install on your project, let's go ahead and just take a look at what we have inside of here. All right, so I'm just going to open my code in my text editor here. I'm using Sublime Text. You can use whatever you'd like. Okay, but we have, a contracts directory that has all the smart contracts for the project, a migrations directory that lets us put these smart contracts in the blockchain. We have our truffle-config file, which connects our project to the blockchain. And finally, we have a script in place that's going to let us actually, create a new proposal, release funds, and we're going to see the DAO in action. Okay, so to create this project, we are going to use some code from OpenZeppelin library as a starting point. So OpenZeppelin actually has a great framework for creating lots of things like ERC20 tokens, ERC721 tokens. So just a translation, that means ERC20 tokens are cryptocurrencies. All right. If you want to create a cryptocurrency on Ethereum or some other EVM compatible chain, you can use an ERC20 token. Many of these are solved problems, so you can get an off-the-shelf solution with a library like OpenZeppelin, and they have great documentation for this stuff. Same thing for NFT, ERC721, and then also for a DAO, okay? They actually have a pretty good suite of tools that lets you create a DAO without having to figure out all the complicated stuff from scratch, okay? So you can see the documentation here on OpenZeppelin governance on how to create a token, all right? How to create the governance contract, and also how to create a time lock. And they go in detail on the proposal lifecycle, how to create a proposal, all right, and how to cast a vote, how to execute a proposal. All right, so we're not going to just read through the documentation in this video. You can check it out. If you want more learnings on that, we're going to show it to you in real time with our coding project, okay? And one of the resources I want to point you to is the OpenZeppelin contracts wizard. So you can see like different contracts like an ERC20 token, ERC721, 1155, and the governor token, which is or the governor contract, which is what we're going to use for the DAO here, okay? And so you can kind of play with this in the UI to try to change some settings like your proposal threshold, the quorum, ERC20 votes, time lock, how you want your DAO to work. You can kind of play around with the settings. It'll spit out some suggestions for you. And of course, you can edit all this yourself as a developer with code, but this will help you get started, and that's what we've done in this video. We've put everything together in a project, and we've shown you how to actually do this, okay? So let's go ahead and open up our project here. Looks like I got two windows. Let me just kill this one. Let's first look at the token contract, okay? All right, so the first contract that we use is the token contract, okay? So this is an ERC20 token. All right, we've just used the OpenZeppelin library, and we have just pulled in the ERC20 library from OpenZeppelin, but specifically, this is a voting token, all right? ERC20 votes is what you want to understand, okay? So this inherits from ERC20, but it also has special voting, capabilities, all right? So it has a mint function and a burn function, but it also has this special after token transfer, logic inside of it, okay? So there's some additional stuff on here, but mostly it works just like a regular ERC20 token, just with a little extra functionality under the hood. So nothing too special here. So the next thing that we want to look at is the Treasury. All right, so the Treasury contract is pretty simple. All right, this is where the Ethereum cryptocurrency is going to go, all right, whenever we want to transfer it, okay? Or that's where it's going to live until we transfer it, all right? And then the next contract is the time lock, all right? This is the time lock controller that just controls the delay, all right, for the delay for the releasing of the funds after the proposal has passed, okay? And then finally is the governance contract, okay? This is the main contract, like we were saying here, from the contracts wizard, the governor, all right, that actually controls, the project. So we've got, it pulls in all the OpenZeppelin contracts, the governor, counting simple, counter votes, quorum, fraction, and then time lock control, okay? And you can see all those here, just like the contract generator. So we'll go over how these work a little bit more in a second, but let's go ahead and look at how we put these contracts on the blockchain and everything that you need to know when you want to deploy it, all right? And then we're going to watch it in action, all right? We're going to demonstrate it, and then we're going to explain it. So we have the contracts coded here. Again, you can see the token settings. You can see the governance contract. You've got the Dapp University DAO as the title here. But let's look at how you put these contracts in the blockchain, because that's going to give some clues into how the relationships work. So what we've done is we've got this deployment script here, all right? And this deployment script just pulls in our contracts that we want to deploy. So we want to deploy the token, the time lock, governance, treasury, and we want to pull some accounts from our wallet here. Now, before I forget, let's go ahead and start Ganache. All right. Just make sure it's actually running the right port here. So this is going to be our development blockchain that lets us, have 10 accounts for free, all right, with fake ether involved. Okay, let's just make sure that we are on the right port here. Truffle-config 7545. Let's see here. Yeah, 7545. Okay, we're connected to Ganache. So we're going to take each of these accounts and assign them a role in this scenario. So account 1 or account 0, I guess you want to say 0, 1, 2, 3, 4, 5. All right. And inside of our migration script, we're going to assign those to each variable. So we use Web3 get accounts to get all the accounts. And we say the executor, the proposer, the voter. All right, 5 voters. So we have the executor. All right. The proposer, this person is going to propose a vote, and these are going to be people who vote on the vote. All right. So this person executes the proposal, this person proposes it, and these people vote on whether they want it to pass. All right. So the first step is we deploy the token. We give it some settings. So Dapp University is the name, DAPU is the symbol, and then we want to give 1,000 tokens. We just want to distribute those initially. Okay. So we deploy the token, and then once it is deployed, we want to take 50 tokens and give them to each of the voters. All right. So after we deploy the contract here, the executor is going to own the tokens. They own it. All right. But then they're going to send 50 tokens to each of the voters. That's what this block here does. All right. Just do token transfer, pass in the voter. So now we want to configure the time lock delay for the vote. So how long we have to wait until we can execute after a proposal has passed. So we're just going to, in a setting of 1 here. All right. So in addition to passing this minimum delay, which is what this is, we also need to set up these 2 arrays. So the first array contains the addresses of all those who are allowed to make a proposal. All right. So we're just going to use the proposer here. This is the person that we just assigned in our scenario. And we also need to have an array of the addresses of people who are allowed to execute the proposals. So that's what this executor is going to be. All right. So we just, you could change this and have a bunch of people could make proposals. And then you could change this to have a bunch of people be executors. These could even be different DAOs if you wanted to, or multi-sigs if you really wanted to. Okay. That could get complex, but you could change that as a coder if you wanted to. All right. And then, that's for the time lock. Okay. And now we deploy the time lock. That's the next steps. We have a token, we have a time lock, and now we want to deploy the governance. Okay. So the governance is going to take some settings like the quorum, the percentage of the total supply of people, or tokens, I should say, that need to approve the proposals. So this is just a percentage. So it's just 5%. So 5% of the tokens need to, make a vote and pass. The voting delay. So how many blocks after a proposal until the vote becomes active? Okay, so we're just going to say 0 for here. And then voting period is how many blocks do you want the vote to stay open? So we're going to say 5 blocks in this case. Okay. So now we're going to deploy the governance. All right, with all these settings. That's exactly what's accepted in the smart contract. And then we get a copy of that. And the final step is really to deploy the treasury. So we've got the token, we've got the time lock, we've got the governance. Now we deploy the treasury where we actually want to hold the Ether funds. Okay. So the time lock will be the owner of the treasury contract. That's what's important to understand here. So once the proposal is successfully executed, the time lock contract is going to be responsible for calling the function. All right. So we're going to give the time lock some Ether. We're going to give it 25 Ether. Okay. And we're going to deploy it. And we're going to tell it who the executor is and how much funds we want to send in that transaction like this. Okay. And then finally, we want to transfer the ownership of the treasury to the time lock address because that's who's going to own it. And then finally, we can just assign the roles. Okay, so we do the proposer role, time lock, proposer role, okay, executor role, and then we grant these roles, which you can see here. So inside the governance, inside of time lock, there's going to be some functions inside of here that says grant role. They're included in the library. You can read about that in the documentation, but that's what we do here in the deployment setup, right? All right, so now let's go ahead and just deploy the contracts to the blockchain so that we can watch this thing in action. So let's do truffle migrate -- reset. And again, make sure that you have Ganache running. Okay. All right, so I'm going to hit enter here. Wait for this to finish. All right, so you'll see all the contracts compile first. That's the first step. And then they are deployed. Okay. All right, so I actually had a little bit of a problem with my deployment here. So Ganache threw an error telling me that I had an invalid opcode whenever I was deploying. So if you encounter this problem, I'm going to show you how to fix it. Okay, so you might be able to continue on with the steps in this tutorial without doing this step, but if you have a problem, I'm going to show you how to fix it on screen. So let's stop Ganache, all right, and let's go to our terminal and open up Ganache CLI. This is the command line version of Ganache. There should be a video in the video vault on how to install that if you haven't already. So we're going to do Ganache CLI -P, which tells it what port to run on, 7545, because inside of our truffle-config file, we connect our project to 7545. So this lets you start Ganache CLI on the correct port to connect to our truffle project without any code changes, all right? Because by default, Ganache CLI starts on port 8545. So we want to start on port 7545. So we're going to do that. We're going to start the blockchain this way. All right, so you still see the 10 accounts here with 100 fake ether. You see their private keys, of course, never use these for real. And we are going to redeploy the contracts here. So we'll do truffle migrate -- reset just to make sure everything deploys properly. All right. So now that works. So I don't have any invalid opcode issues. So now that we have the contracts deployed, we actually want to run the script to watch this governance process in action, all right? And so in order to do that, I actually want to redeploy the contracts. I meant to just do this. Because we're changing Ganache CLI versus Ganache GUI, I'm actually going to go to line 26 in this deploy contracts tab here, all right? This deploy contracts file. I'm going to change it to 0. So that's not part of the original demonstration, but if you're using Ganache CLI, we're just going to change the delay. This is how long you have to wait until we can execute a passed proposal, okay? So we're just going to adapt this for development purposes because we had a technical glitch. Sometimes this stuff happens when you're developing for blockchain, but you should be able to create real delays on real blockchains by changing this value, okay? So let's redeploy the contracts again. Sorry, truffle migrate -- reset. We modify our migration script, so we want to redeploy. And I actually kind of like leaving these problems inside the videos. You know, you might think you have a perfect video without any problems, but this is what it's like to build software. And me teaching you how I'm fixing this problem as I encounter it can impart some of that problem-solving knowledge to you and add more tools to your tool belt. All right. So now let's actually run the script so that we can watch the governance process take place. Then we'll explain it. So we'll do truffle exec. I'm going to pull my screen up here so you can see it. Scripts, and we'll say _create proposal. All right. And this is going to actually do a governance proposal and vote on it. So you can see all of the you can see all this logged at the console here. So we start off, are the funds released? No, so they're in the Treasury. So we have 25 ETH inside the Treasury. We created this proposal right here. All right, the current state of the proposal is 0. It's pending, all right? So it was created at block 36. The proposal deadline is block 41. So the current block number is 36. Number of votes required to pass is 50. All right, so we're casting votes. Current state of proposal is active. All right, so proposal state is changed. Votes for, all right, 150. Votes against, 50. Votes neutral or abstained is 50. All right, so current block is number 42. And we have enough votes to pass. So the state of proposal is succeeded. And then once it's succeeded, there's technically the delay before it can get executed. So we stick it in the queue. We wait for the delay to pass. And now it is executed. And the funds have been released from the Treasury. That's true. And now there is 0 ETH inside the Treasury, and it has been sent to the recipient. All right. So let's just go and take a look at that here in this create proposal script. All right. So we pull in the token, time lock governance Treasury. We set up the people in the scenario. Just like we saw in the migration script. All right, we set those as variables. We track the state of, are the funds released? How much funds? What's the block number? What's the proposal state? What's the vote? The amount is Web3 utils 2-way 5 ether. All right. And then the token is a wait token deployed. Okay. And then we basically delegate tokens from each voter. All right. And then we get the Treasury. We try to see the state of the Treasury. Are the funds released? So the answer is no. Whenever we run this the first time, we get the balance of the funds, all right, inside the Treasury. So it's just get balance of the Treasury address to see how much Ether it does. That's what Web3 get balance does. Gives you the Ether balance, all right. You get the governance contract, all right. And then we, here's where things get interesting. You can basically tell, like whenever you're doing a proposal, your proposal is to call a function on another smart contract. So this is how we do that. So we say await Treasury contract methods release funds. We return the function itself that we want to call, and we say encode ABI. All right, we basically write it in a way that we can tell another smart contract to call this method, and that's the function that we want to call. All right, and we say, release funds from Treasury. That's the description of the encoded function. And so we're having a proposal to call this function on another smart contract. And so we just pass in the encoded function here, the description from proposer, the Treasury address. So this is the recipient, and then this is the encoded function and the description, right? So we show the created proposal here, the ID of it. We say the state of the proposal is now pending, all right? We take a snapshot of governance, okay? We get the deadline, all right? And then we get the block number, current block number, all right? And then we look at the quorum here, okay? And then we cast the votes. Cast vote 1, 2, 3, 4, 5, and we say 0 for against, or 0 votes against, 1 for, 2 abstain. All right. And then we get the proposal state, we transfer the tokens for the execution, and then the next thing that we do here is actually get the proposed votes. All right. We see how many are against, how many for, how many abstained. We log that out to the console so that we can verify that happened on the blockchain. We get the block number again to make sure that it can happen, it can pass. We get the proposal state. It's now succeeded. All right. And then now we queue it to release funds from the Treasury. And then we execute it. All right. So the execute is just on the governance contract. We call execute. It has to come from the correct address, which is the executor. And then, you basically allow it to do that. So here's the proposed state. Is it released? And then here are the funds. Okay. And that's the final state. All right, and so that's an overview on how to create a decentralized autonomous organization, or a DAO. Again, DAOs have a huge promise for the future, okay, on how we can coordinate people online, how we can manage money, how can we manage organizations where people don't have to trust each other, they don't have to understand each other's identities, but they can still coalesce around a common goal with blockchain technology where code is law, powered by smart contracts. All right, so that's all I got for today. As always, smash that like button down below for the YouTube algorithm. Subscribe to this channel if you haven't already. That really helps these videos out so that more people can learn about blockchain. And if you like this video and you want to see more videos just like this, then I can show you how to become a blockchain master step-by-step, start to finish, over at dappuniversity.com/bootcamp. You don't have to be an expert to get started today. I've helped people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.